Hello everyone. Today's presentation is about the topic image intensifier. Image intensifier is a part of the SIAM mission. SIAM mission is nothing but the mission that we usually use in the cath lab. This image intensifier is the X-ray detector that captures the X-ray photons or X-ray beams and converts them into visible light and then creates a digital image, which means the image intensifier will capture or obtain all the X-ray beams that are emitting out of the X-ray tubes and convert them into a real-time image. So nowadays the image intensifier is modernized into a new version and it is called as the flat panel detectors. This flat panel detectors are more modern and it offers a better image quality with lower radiation exposure. In this image you can see a standard SIAM, and the upper portion you can see the image intensifier and the lower portion you can see the X-ray tubes which usually emits the X-ray beams. Okay, in this image you can see the X-ray beams are coming out of the X-ray tube and it is passing through the patient's body, and the image intensifier is absorbing or capturing all the beams that is passing through the patient's body, and after it captures this beams it converts them into real time imaging, and we can see those images in the monitor. And this image is the outline view of the image intensifier. In this we can see the parts of the image intensifier: the input window, input phosphor, photocathode, focusing electrodes, anode, output phosphor, and we also see the dark black line, and it is called the housing, which is the outermost layer of the image intensifier. So now we can see the working of image intensifier. First, the X-ray beams are coming out of the X-ray tube and it is passing through the patient and it reaches the anti-scatter grid. This grid is the outermost or the first covering of the image intensifier. Okay, so now the grid is reducing the amount of scatter radiation. So, and it passed through the input phosphor. So first the beams are passing the anti-scatter grid and now it reaches to the input phosphor. So now the anti-scattering grid is reducing the radiation and it will give a good image contrast. Then the X-rays will strike the input phosphor. This input phosphor is made of a material called cesium iodide. So this cesium iodide can convert a small number of X-rays into many light photons. There are highly packed needle-shaped iodide crystals which direct the light in straight lines. It helps the lines to travel in a correct direction, which is helping them to prevent the light dispersion and improving the spatial resolution, which means it gives a great results with minute details. So next component is the photocathode. This photocathode is directly bonded to the input phosphor. So photocathode is a thin metal layer usually composed of cesium and antimony compounds. These are some kind of chemical compounds, and the light photons are emitted. When the light photons are emitted from the input phosphor, it stimulates the photocathode. Then the photoelectrons are released through photoemission. On the other end of the image intensifying tube, you can see a positively charged accelerating anode. This anode has a small hole in the middle. And this photoelectrons which are emitted from the photocathode are traveling through the hole and it strikes the output phosphor. The image intensifier tube is lined with negatively charged electrostatic focusing lenses. These lenses are positioned in such a way that they help to funnel the photoelectrons into a concentrated stream, which means these lenses are helping the electrons to go in a correct direction or correct pathway. These photoelectron stream passes through the hole in the accelerating anode and it hits the output phosphor. Output phosphor is in the other end of the image intensifier. Okay, this output phosphor is made of a material called zinc cadmium sulfide. The output phosphor converts the photoelectron stream back to light photons. The anode is positively charged with 25,000 to 35,000 volts. The next thing is CCDs. This CCD is called charge coupled device camera. It is a type of camera that converts the light photons to electrical signals, and also it collects the electrical signals and send them to a converter. It is an analog to digital converter. So it converts the signals one last time into a digital signal. So this digital signal is then sent to a monitor that we were accessing to. So finally, we will get a real time image of what is happening during the overall procedure. So now the summary. So we can recall what we have learned throughout this presentation. So first, the X-ray tube is emitting the X-ray beams, which is passing through the patient, and the image intensifier is capturing it. And the first thing is the input phosphor, which converts the X-ray beams into light photons. And then the photocathode is converting the light photons into photoelectrons, and then the output phosphor is converting those photoelectrons back into the light photons. Next, the analog to digital conversion is converting them into analog to digital signals, and finally we'll get a real time image of the procedure. Thank you everyone.